In this lesson, we're going to talk about work and energy. Now, we remember from before that there's a few different types of energy. We can talk about kinetic energy, which is due to velocity, and we calculate it 1/2 mass times velocity squared. And there's a potential energy. We have a couple different types of this. Gravitational potential energy depends on the mass in the gravitational field, and we calculate it by taking mass times the strength of the gravitational field times height. There's elastic potential energy, which depends on the spring or the elastic band that the elastic energy is stored in. We won't get into that equation, but we have these two forms of energy. Now the question becomes, how do I get something to have energy in the first place? Well, the answer is we have to transfer energy to it. And transferring energy to it involves work. And in fact, that is one definition of work. Work is the transfer of energy. So the amount of work done is equal to the amount of energy that is transferred, either to or from an object. The other definition of work is how we actually carry out work. Work is done by a force acting through a distance. Work equals force times distance. Now, there is the idea of both positive and negative work. Positive work means that I'm transferring energy to an object and it gains energy. It also means that if I apply a force on an object, I apply that force in the same direction the object is moving. So for instance, if I have a cart sitting here and I exert a force this way on it, causing it to move that direction, then this cart will speed up. And because it's sped up, it will have gained kinetic energy. And so what I can say is the work that I did transferred energy to it, and it gained kinetic energy. So I can say that work is the transfer of energy, and the amount of work done is the amount of energy transferred. Okay. So that's kind of a big deal. If we know how much work is done, we know how much energy is transferred. But that means I could just look at the initial velocity, the final velocity, and the mass of the cart to figure out how much work I did. But if I was measuring the force through the distance through which it acted, I could also use that equation, and they would work out the same. So work equals force times distance. Now, there is a caveat on this. I said positive work means this thing will gain energy, but what if I exerted a force backwards on it if it was moving this way? That would cause it to slow down and stop, and that would actually cause its kinetic energy to go down. So that's because my force and motion were in opposite directions. So I said work is force times distance. This is positive. Probably shouldn't put that. Positive if the force and motion are in the same direction. However, if they're in opposite directions, it's negative. So it's negative if the force and motion are opposite. Now, let's get back to this cart. Okay? If I exerted a force either left or right and caused it to speed up or slow down either to the left or to the right, then I did either positive or negative work. But those aren't the only forces that are acting, right? Because there is gravity, which pulls it down, and there is the normal force, or the force from the surface, which pushes it up. Those two forces didn't do any work because they are perpendicular to the motion. So forces perpendicular to the motion do no work. Okay. And in fact, you can have forces that are in between that will only do some work. We won't get too much into that. So, work transfers energy. The amount of energy transferred is equal to the amount of work done. Positive work causes an object to gain energy. Negative work causes the object to lose energy. And so far we've looked at this in terms of strictly kinetic energy, but it's kind of applicable to the potential energy realm as well. If I have something that is moving up a ramp, once it gets to the top of that ramp, it will, well, anywhere along that really, if I'm pulling this thing along the ramp, I'm doing work on it. Even if I'm pulling it at a constant speed and its velocity isn't changing, I'm still doing work. I'm exerting a force through a distance. And it has now the ability to roll back down that ramp, which means the work I'm doing is not giving it kinetic energy, but rather potential energy, because gravity has the potential to pull it back down the incline or drop it off the side.